Unit 6 notes, mean and mean absolute deviation. The learning target for today's notes is I can determine the mean absolute deviation for a set of data. Example 1. Mrs. Hicks and Mrs. McWilliams wants to make sure the algebra students are performing similarly. The tables below show some of the students in their class and their grades on the most recent quiz. So we have two tables for Mrs. Hicks' class quiz grades and Mrs. McWilliams' class quiz grades. Number 1, what is the mean grade for each class? So mean means average. And in order to figure out the average for each grades, we would have to add up all of the quiz grades and then divide it by the number of grades we have. So for Mrs. Hicks, we have 70 for Mary, 95 for Chung, 73 for Skylar, 86 for Zoe, 82 for Asia, and 92 for Elizabeth. Once we add all of them up, we would have to divide it by the number of scores we have. And we have 1, 2, 3, 4, 5, 6. So this is how you plug it into your calculator. Make sure you use the fraction symbol, and then you put all of those numbers on the top, the sum of them, and then the 6 on the bottom, and then execute. And you should end up with 83. Now let's figure out the third column. It says distance from the mean, meaning you would have to figure out what would be the difference between the mean and their quiz grades. So for Mary, we would have to do 83 minus 70, and that should give you 13. 83 minus, or we would have to do the bigger number minus the smaller. And that would be 12. 83 minus 73, that would be 10. 86 minus 83, that would be 3. 83 minus 82, that would be 1. 83 minus, again, 92 minus 83 would be 9. So now we have all of our differences from the mean to the actual score. Okay. So we are going to do the same thing with Mrs. McWilliams' column. So again, on your calculators, to figure out the mean first, you would have to put the fraction line. And you need to plug in all of the scores. 43, 92, 97, 67, 100, and 99. And then we have 6 scores again. So once you have plugged that into your calculator, that should give you a mean of 83 again. So we have the same means, but we have different scores. So again, in order to figure out the distance from the mean, we would have to subtract the bigger number minus the smaller number. For Kevin, it's going to be 83 minus 43. That's 40. 92 minus 83, that's going to give you 9. 97 minus 83, it's 14. 83 minus 67, that's 16. 100 minus 83, that's 17. 99 minus 83, that's 16. So now we have our tables completed with the means. Let's move on to number 2. It says complete the table by listing the absolute distance each value is from the mean. We completed that. If we wanted to know the average distance each grade was from the mean, we would find a measure called the mean absolute deviation. And this is what we're learning today. This measures the variance of a set of data. In other words, how spread out the set of data is. Procedure for determining mean absolute deviation. Determine the average, which is also known as the mean, for the original data set. Subtract each individual data point from the average of the original data set. That's exactly what we did. Step number 3, determine the average, which is again the mean of the new data numbers. So now what it's telling us to do, so what we did not do yet is the third step, which is determine the average mean of the new data numbers of what the differences were from this column and this column. So we again have to find the average of the distances that we got from the mean. So let's use those numbers that we highlighted, 13, 12, 10, 3, 1, and 9, and figure out the average for that. So for Mrs. Hicks, it's going to be 13 plus 12 plus 10 plus 3 plus 1 plus 9, all over 6, and that should give you, if you plug it into your calculators, 8. Now let's look at Mrs. McWilliams. We have 40, 9, 14, 16, 17, and 16. Plug that into your calculator again. All over 6. And that gives you 18.6 repeating, or 18 2/3. So now, what can we say about these mean absolute deviations that we just got for Mrs. Hicks and Mrs. McWilliams' class? Although their mean was the same, we got different mean absolute deviations. Let's think about what mean absolute deviation means. It's the variance of a set of data, in other words, how spread out the set of data is. So what conclusion can we make? Number 4. What can we conclude about the two scores and the mean absolute deviations? Well, although the two means were the same, Mrs. Hicks' class was more consistent with their quiz grades due to a lower mean absolute deviation. Okay, so mean absolute deviation can be abbreviated with MAD, MAD. So although they had the same mean, we can say that Mrs. Hicks' class, their scores were closer to each other. The spread of it was a lot closer. Whereas Mrs. McWilliams, you can see by looking at their grades, the quiz grades were not as close together, so the spread was a lot further. That is the reason why their mean absolute deviation was a lot further apart. So Mrs. McWilliams was 18.6 and Mrs. Hicks was 8. So we can say that Mrs. Hicks' grades were a lot more consistent. Example number 2. Consider the two basketball players below. The table shows how many points each made in their last 8 games. So now we have two different scores for Kobe Bryant and LeBron James. So we first need to figure out the mean for each one, just like what we've been doing. So the mean for Kobe Bryant, it's going to be 21 plus 39 plus 28 plus 21 plus 31 plus 19 plus 27 plus 26. Make it smaller. All over 1, 2, 3, 4, 5, 6, 7, 8. We have 8 different games. So once you get the mean for the Kobe Bryant, it should be 26.5. So Kobe Bryant's average would be 26.5. Okay. Now let's look at LeBron James mean. Okay, so we have 22 plus 31 plus 11 plus 36 plus 17 plus 18 plus 12 plus 26. All over 8 games again. And if you do that on your calculator, that gives you 21.625. Okay. And now we have both means. Now we need to find number 2, the mean absolute deviation for each player. So we're going to do the MAD. Okay, and I'm going to subtract the 21 from the 26.5 and list out the differences for all of them. If you do each one, you get a list of numbers of 26.5 minus 21, 5.5, 12.5, 1.5, 5.5, 7.5, 0.5, and then 0.5. And I left off the 26. Okay. And then once you get the differences, you can divide it by 8 again. And if you do that, it gives you 4.75. So we're going to do the mean absolute deviation for LeBron James. And we know that these numbers are going to be a little long because of the decimal. So I'm going to go ahead and just write it really small. So we know that's all over 8. If you subtract 21.625 from all of those numbers and you figure out the difference in between them, the first one's going to give you 375 plus 9.375 plus 10.625 plus 14.375 plus 4.625. Already losing room, so I'm going to make this smaller. 4.625 plus 3.625 plus 9.625. Then let's make it smaller again. And then finally, 4.375. All right, we got all those numbers. Now, if you plug all of them into your calculators, that should give you a MAD of 7.125. So also practice plugging in the numbers correctly into your calculators. All right, so that should have given you 7.125 for LeBron. And now we can make a conclusion. So it definitely seems like Kobe was the lower MAD, meaning based on the data, we can say that Kobe had the more consistent player data games. Okay, so based on the data, Kobe Bryant is the more consistent player. Okay. All right, so example number 3. Consider the 4 basketball players below. Determine the mean absolute deviation for each. So again, we need to figure out the mean for each one. So I'm going to write the mean for each one on the top of their tables of scores. I know I'm just going to add 23 plus 14 plus 31 plus 17. Again, 23 plus 14 plus 31 plus 17. All divided by 4, that gives you 21.25. For Chris Bosch, we know it's going to be 20 plus 24 plus 23 plus 21 all over 4. That's going to give you 22. For Dirk, we know it's going to be 17 plus 17 plus 17 plus 17 all over, it's 27. 17 plus 27 plus 17 plus 27 all over 4, it's going to be 22. And then for Dwayne, it's going to be 20 plus 25 plus 25 plus 19 all over 4. That's going to give you 22.25. All right, so I put the mean on the top, and then it's asking for the MAD for each. Now I'm going to subtract the mean with each score so that I can figure out the distance, and I'm going to put it right next to each score so that we can just do it easily at the end. So 21.25 subtracted from 23, since it's the bigger number, it's going to give you 1.75. 21.25 minus 14 is 7.25. 31 minus 21.25 is 9.75. 21.25 minus 17 is 4.25. Next one, 22 minus 20 is 2. 24 minus 22 is 2. 23 minus 22 is 1. 22 minus 21 is 1. 22 minus 17 is 5. 22 minus from 27 is 5. 22 minus 17 is 5. 27 minus 22 is 5. And then finally, 22.25 minus 20 is 2.25. 25 minus 22.5 is 2.75. 25 minus 22.25 again is 2.75. And 22.25 minus 19 is 3.25. All right, so now we can figure out our MADs. So for the first one, we're using our blue numbers for our differences. So we need to put it in the fraction line, 1.75 plus 7.25 plus 9.75 plus 4.25 all over 4 should give you 5.75 on your calculators. Next one, 2 plus 2 plus 1 plus 1 all over 4. That should give you 1.5. 5 plus 5 plus 5 plus 5 all over 4. That should give you 5. Then finally, 2.25 plus 2.75 plus 2.75 plus 3.25 all over 4 should give you 2.75. So we have our mean absolute deviations for all 4 players. Number 1, who is the most consistent player? Well, we know that the smallest number will always be the most consistent number or data point. So we know that Chris Bosch is going to be the most consistent because it has the lowest MAD. Number 2, who is the most inconsistent? And we're looking now at the largest MAD, which is Blake Griffin, because he has the largest MAD. Okay, and that's it. Now try the last question by yourself by using the notes that I gave you from the first page. Okay, good luck.